that the implants can be tailored towards each individual patient in this technology. There's also an advantage that in these implants, with the 3D printing, the surface can be shaped in a way that facilitates bone ingrowth. So the bone doesn't like if the implant is perfectly smooth. That wouldn't be good. So if the surface of the implant has certain roughness, certain cellular structure, that's good for growing. And aerospace obviously is the other very big driver. But there's increasingly more and more industries that use additive manufacturing really across the spectrum for a wide variety of parts.
Yeah, so where do you see this industry going? Do you think it's going to be smaller machines eventually?
I think there's clearly a trend towards a more diversified landscape. When we started out here about 5 years ago, there were relatively few machine manufacturers and they would all build sort of more or less the same sort of type machine. Now it's more and more diversified. There are new companies on the field to try to go into the metals for the hobbyist market, so these are much smaller printers, less expensive. And then of course there's also the other end, still catering towards the high end, the aerospace, where we see an expansion in the size of the parts.
Yeah.
So there's always a driver for larger and larger parts, but we don't want to sacrifice quality. So larger parts, but overall I would say far more diversified machines are really catering to the different application areas. There's a need for faster machines. You said this takes 5 hours for a relatively small part, so it would be good to have a higher throughput. That's another area companies are working on. How can we speed up the process?
Yeah, great. And this machine here, what would you say, 2 million, 3 million?
No. This is probably closer to 1 million at this point.
Great. And then how many of these machines do you have here?
We have one of this type, and then in the other little rooms that we have in this lab, we have another machine also using a laser. That's an EOS machine. Then we have a machine, an arcane machine that's using electron beam that looks like a big refrigerator essentially. It's always the same technology. We have to bring out the powder, you melt each layer. It's either laser beam or electron beam, and then again you're setting up our own machine. It's also using a laser, but it has a number of advantages over these commercial machines.
And again, it's building layer after layer. So this is only layer 4 of 391.
That's correct, so that's why it takes 5 hours, but still the beam is relatively fast, so the beam typically moves with a speed of a few meters, or maybe 1, 2, 3 meters per second. So the beam itself is relatively fast, but it has to cover quite a bit of area on the build plate.